This lesson is the last of the 3 word problem lessons. We're going to examine some slightly more complicated shape problems. So ones that are maybe rectangles, but they're rectangles inside rectangles, or there's something going on in them. Okay. When we do these questions, my biggest suggestion is draw a diagram. Okay. Label some things in there, put some variables inside your diagram. Think about what the question is trying to tell you to help yourself make an equation. And so we're going to try a couple of examples. I have 3 for you guys today. And to give you what I would suggest is I'll show you the first one, pause it, try the second one yourself, and see if you can figure out what's going on here. So let's take a look at the first example. A rectangular sheet of tin, 15 centimeters long, 9 centimeters wide. A uniform strip is about to be cut off it. So if we take a rectangle, let's get our rectangle making shape here. Here's my rectangle. It's 9 by 15. So 15 centimeters, 9 centimeters. And I want to cut some off. Uniform strip. What does that mean? That means it's equal width. And it's the same size all the way around. So I'm going to cut some off. I'm going to cut off a piece here. And cut off the same amount down here. I'm going to cut off the same amount from this side. I'm going to cut off the same amount from this side. And those pieces are now gone. So it used to be 15 by 9, but it's not anymore. I cut some off. The question is, how much did I cut off? So this distance here, we'll call that x. Well, that means this is the same distance, x, which means this is the same distance, x, and this is the same distance, x, which means that the remaining size, which used to be 15 long, has lost an x from each of it. So in other words, it's now 15 minus 2 x's. And it used to be 9 centimeters wide, but I cut an x off from the top and the bottom, so now I've got 9 minus 2x. And that's the dimensions of the remaining sheet, the part in the middle. They tell us in the question the remaining area is 112. And now the area is length times width. Well, if I know the area is 112, and I know that the length, which used to be 15, has lost an x from each side, and the width, which used to be 9, has lost from an x from each side, I can make an equation. And to solve equations, under quadratics, I have to make it equal to 0 and put it in standard form. So I'm going to FOIL. I'm going to multiply all these pieces. Oops, that's not the right number there, sorry. 15 times 9 is the 135. 15 times 2 is minus 30x. That was my mistake there. Minus 18x plus 4x squared. And if I can squish it in over here, move this over a little bit, I want to put the minus 112 to make it equal to 0. And if I collect my like terms, I get 4x squared, which is nice, minus 48x's, and plus 23, the 135 minus 112. Okay, so I've got a quadratic standard form. Let's try factoring. First thing you notice when I try factoring is there's no common factor. So I have a complex trinomial. And complex trinomials have a process to them. There are 3 steps. So it might be just as fast to use the formula in this case. So let's do that. The opposite of b plus or minus b squared minus 4 times a times c, all divided by 2a's. And let's make sure we can actually calculate this. Find our discriminant. Under the square root, I got 1936, which is positive, so I can find it. So let's do that. Okay, 2 answers. I get 11.5, and I get 0.5. As I said in the previous lesson, when you do shape questions, you usually have one that's inadmissible. In fact, you have to have one that's inadmissible. But right now, I have 2 positive answers, so they both seem admissible, at least until we go back to the question. The whole idea of x is the amount that you're cutting off. So if I look at this and I say to myself, well, I've only got a 9 centimeter wide piece of tin, and I need to cut 11.5 centimeters off the top and bottom of that. Well, that's not possible. You can't cut that off. You wouldn't have anything left. In fact, you'd go into the hole. So this is the inadmissible answer. It's too big to cut off, which means the other one has to be the right answer. The width of the strip is 0.5 centimeters wide. So the big idea in this question is trying to make that equation. That's going to be our tricky part. It's kind of like when we did trigonometry way back when. The picture is the challenging part. The math, the factoring or quadratic formula or foiling, that's pretty standard now. It's getting that picture in the equation in the first place. So let's try some more. Example number 2. A square lawn is surrounded by a walk 1 meter wide. Okay, so you can turn that into a picture. I need a square. It's a square. And I need it to have a walkway around it that's 1 meter wide. Well, if it's all 1 meter wide, then it's going to be a uniform shape again. So let's line this up a little bit here better. That looks better. So my square lawn is surrounded by a walk that's 1 meter. So I know that's 1. I know this is 1. I know this is 1. I know this is 1. The area of the lawn is equal to the area of the walk. So the lawn equals the walk. Okay. Find the length of the side of the lawn to the nearest tenth of a meter. How big is the lawn itself? I don't know. That's what I'm being asked to find. So that's where my x comes into play. The lawn is x by x. Remember, it's a square. Well, that means that the area of the lawn is x times x. So in other words, x squared. And we said that the walk is the same size, so x squared. So if I look at this shape, I think of it as one big shape, just a big shape. How big is it from the top all the way to the bottom? Well, up to here is 1 meter. This we said was x meters, and this we said was 1 meter. So I hope you would agree that this whole thing is x plus 2. And because it's a square, this is also x plus 2. So if I want to talk about the area of this entire shape, the whole shape, the area is the length times width, or in this case, length times length is a square. I know some things. I know the inside shape, the lawn, is x squared. I know the walk itself, also x squared. So the area of the whole thing is x squared plus x squared, the lawn and the walk together. And I know that the dimensions of the lawn and the walk together are x plus 2 times x plus 2. So when I look at this question, I have to take two shapes separately and put them together, the area of the whole thing. In the previous question, we were told the area. Here, I have to figure it out. So let's turn this into a quadratic. I want to make this equal to 0. I need to FOIL. So x squared, 2x, 2x, and 4. And I need to bring these two things over here. So minus x squared and minus x squared. What will that give us? If we collect our like terms, we get negative 1x squared plus 4x plus 4. Okay, that seems pretty small. It's in standard form. It's equal to 0. Let's try factoring. I don't like having negative x squared. Let's get rid of that. So x squared minus 4x minus 4. Can we think of anything that multiplies to negative 4 and also adds to negative 4? I can't. I can't off the top of my head. I don't think that's possible. So I got to go to the formula. The opposite of b. Now I have a choice. I could use this line, or I can use the parts inside here. It doesn't make a difference which one you use. I'm just going to use, I'll use the original one, this one up here. Okay, so the opposite of b is negative 4 plus or minus b squared minus 4 times a times c all over 2a. Hey, let's see if this is possible. Can we get a lawn that's the same size as our walk? Well, if I do my discriminant, I get 16 plus 16 makes 32. Yep, I can. It can be solved. I just got to figure out the answers. All right, two answers. First one, ooh, negative 0.828. Oh, you know, right off the bat, that's an inadmissible answer. I can't have a negative length lawn. And the other answer that I got was 4.828. Well, that must be the answer. That's the positive one. Therefore, the lawn is 4.8, go 3 by 4.83. How about 3 sig figs? Done. I solved it. Okay, let's see if you guys can try one. If you haven't tried the last one, try this one. So a landscaper has decided to build a uniform walkway, there's that word again, uniform, around a rectangular garden which measures 12 by 18. So let's draw that right off the bat. We need a rectangle, it's 12 by 18. That's pretty good. It's 12 by 18. You're putting a walkway around it, which means you need another rectangle. And it's got to be uniform, so I'll have to fix that in a second. That looks pretty uniform. Okay, what do we know? It has been decided that it would look best if the area of the walkway was equal to the area of the garden. So the walkway equals the garden. Okay. How wide should the walkway be? We don't know, but we know it's uniform. So X and X and X and X. Okay, let's take out the things we do know. We know how big the garden is. The garden is 12 by 18, which if I multiply those two things together, I get 216, which means the walkway is also 216 because they're equal to each other. Which means if I think of this as a one big shape, the big rectangle, the whole shape area is made up of a rectangle, which is length times width. The whole thing is the 216 plus the 216. How long is the whole shape? Well, if we draw this out, the length of this, it's got three parts. It's got the x part, the 18, and the x. In other words, it's 18 plus 2 x's. If we do the same thing for the width, it would make sense that it would be 12 plus 2 x's. And there's an equation. We can solve this equation. We gotta do some FOIL, some rearranging. We gotta make it equal to 0. Well, we can do that. I'm just gonna move this over a little bit because I don't think it's gonna fit. Okay, so let's do some math here. What do we got? 18 times 12, we already did that one, it's 216. Plus 36x plus 24x plus 4x squared. And I gotta bring over those minus 216s. Make it easier for ourselves. Let's collect up our like terms. We'll get 60x's and minus 216. Okay, it's ready to be solved. It's equal to 0 now. Let's try factoring, make it easier. These are big numbers, let's make them small numbers. 216 divided by 4, that's what, 54? Okay, let's try some man. Multiply 54, add to 15. Can you think of any numbers that do? There are numbers this time. The numbers are x plus 18 and x minus 3, which means my zeros are negative 18. Uh-oh, negative answer. Right off the bat, we know that's inadmissible. And 3. Oh, we're done. The walkway should be 3 meters wide. Done. That's all we need. Okay, last one. If you didn't try that one, try this one. A picture that measures 10 by 8 is to be surrounded by a mat before being framed. Okay, so I'm going to guess we got ourselves a nice little rectangle here, 10 by 8. 10, 8. The width of the mat is to be the same on all sides of the picture. So this is like that background sort of thing. Okay, so we need a nice little rectangle there, and a uniform rectangle. So we got x, and x, and x, and x. And from previous knowledge, we know this is 10 plus 2x and 8 plus 2x. Okay, the area of the mat is to be half the area of the picture. Oh, that's something new. The mat equals half of the picture. Okay, what is the width of the mat? So let's find the area of the picture. The picture is 10 by 8. So 1/2 times 10 by 8 is 40. So that means the mat is 40. Okay, so what's the area? What do we got to make an equation here? So the area of the whole thing, the total, is area equals length times width. So here's where you have to think a little bit. What is the total area? The area is made up of the picture and the mat. Now the picture isn't 40. The picture itself is 10 by 8. It's 80. The mat is 40. So notice that we have two parts here, the picture and the mat. The overall shape is 8 plus 2x times 10 plus 2x. Okay, so two things going on there. We've got the area of the picture and the area of the mat. Okay, let's do our math, our standard math here. Let's do our FOIL. 80 plus 16x plus 20x plus 4x squared minus the 80 minus the 40. Okay, so we're collecting, so 4x squared, 36x is in minus 40. Okay, ready to go. Standard form equal to 0. Let's try solving. Okay, make it easier first. Oh, that's an easy one. I can think of numbers that multiply at negative 10 and add to 9. That's just 10 and 1. So my answers are negative 10. Oh, negatives. No, those are inadmissible. Or 1. Okay. The mat should be 1 centimeter wide. And we're done. And that's our last series of word problems. Slightly more complicated. You have to think about that equation, how you're going to build it, and the relationship between the shape on the inside and the shape on the outside. Okay, the homework is on the second half of the handout from yesterday, so on the website there, print it off, and so are the answers. You can check things out. And then we're kind of done with word problems for a bit.